Then we come to insight 2, which is the evidence that we have gone into a period of exponential, an unprecedented rise in pressure on the planet. In fact, we know today that we have the great acceleration starting from the mid-1950s onwards. And let me just try one thing here and see if this film starts. No, it doesn't. Okay, so we'll do it just from the graph. And what you see on these graphs is the following. And you don't have to care about the numbers. You just have to look at the patterns. And the patterns is that they are at the same kind of pattern from happening nothing up until a certain point, and then they start very rapidly. And what you have on the x-axis is from 1750 until today. 1750 is when in United Kingdom we invented the Industrial Revolution through the coal-based steam engine. And what you see if you look at the graphs, these are the pressures that we cause on the planet, from carbon dioxide emissions to deforestation, loss of biodiversity, acidification, overuse of metals, plastics. It's basically every parameter you can think of that we depend on from planet Earth. And if you look carefully, the pattern is nothing, 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 until a point at which it says hockey stick bang to the ceiling. And the point is now precisely defined as 1955. So 1955, science has concluded we start what is now called the moment of the great acceleration. Now, this is 10 years after the Second World War. We're 3 billion people, we're less than half of today, and something very special happens in the world. We've come so far in our industrial evolution from the Industrial Revolution in 1750. So we have technology. It's come to real scale through railway and aircraft and transport. And 10 years after the Second World War, we have so stable, peaceful conditions that we are at this perfect phase when we can spread out and start really exploiting the entire planet for the first time. But what you see is that up until that point, we have very little impact on the planet as a whole. So we are really a very small world on a big planet. But then you see we start our exponential rise, and it's an extraordinary period. It's when I'm born. Well, that's not the extraordinary thing, by the way. It's 1960s, 1970s, 1980s. And, we just go on with economic growth, and we go on with exploiting metals, soils, biodiversity, forests. We emit greenhouse gases. The atmosphere takes up more and more, and nothing happens. Because the planet is so strong. It's so what we call resilient. It has so much redundant capacity that there's enough atmosphere for us to pollute it. There is enough soil for us to degrade it. There's enough forest for us to cut it down. There are enough species for us to lose a few. There's so much fish in the ocean. You can just, unsustainably fish the cod in the Baltic and the salmon everywhere, and things just deliver to our economy. And this is I'm sorry to say, your parent generation, including myself. And we live in this era where economic growth first delivers so well that we exponentially rise, but then you see we come to 1990. So in 1990, I think still a little bit before you're born, we start seeing the first scientific signs that this does not work. That we have the cod fisheries outside of Newfoundland collapsing. We have the Baltic Sea collapsing into its algal bloom state we are so familiar with today, with dead zones in 60% of its bottom. We see the atmosphere actually saturated with greenhouse gases for the first time. We see accelerated ice melt in the Arctic. We see coral reefs starting to collapse because of bleaching and warming. We see the first signs of air pollution really occurring at the large scale. We see lakes tipping over in North America due to too much nitrogen and phosphorus from modern agriculture. So from 1990 onwards, science starts for the first time delivering its evidence that we may have started to hit the ceiling of what the planet can cope with. We have what science says, in a very, I think, eloquent but also dramatic way, reached a saturation point. We've filled up the entire planetary space, from the atmosphere, the stratosphere, the hydrosphere, and the biosphere. We have suddenly turned a page. But the trick is that the science evidence has traditionally always lagged behind the political and kind of societal action. Because you know how science is, it has uncertainty and it builds up its knowledge. So it has taken roughly 25 years from that point in 1990 until the world starts recognizing, yes, we're facing what we call risk of real abrupt tipping points. If we push things too far, things can actually change. So dear friends, insight number 2 is we are actually entering a new geological epoch. We're leaving the Holocene and welcome to the Anthropocene. Anthros for us humans, anthros Latin for humans, and a new geological epoch, Anthropocene. The Anthropocene, good news, is not a new state of the planet. We're still in the Holocene in terms of how nature basically operates, but we're in the Anthropocene because we humans have become the dominant force of change at the planetary scale. We're now in the driving seat. We are a larger force of change than the sun and our position vis-a-vis other planets in the universe. So that's the big insight. But the key is we have from 1990 turned a page into a new logic where we now have saturated the whole system and that we risk abrupt changes. And that is a new insight where we, up until 1990, were a relatively small world on a large planet. And now you're living up in this situation. We're now a big world on a small planet. And this is the number 2 insight, and this is starting to be now understood in full, and that's why we see this action 2015. Okay, so that's insight 2. The number 1 is the Holocene, number 2 is the Anthropocene. So now comes number 3, which is kind of the toughest one, which is that the world looks a bit like this.